Not much time left, maybe 5 minutes. So maybe we can just do some quick graphing. This is a straightforward problem. Would you be able to recognize the graph of e to the x minus 4? Follow-up question. Could you describe its end behavior using those arrows? When x goes to infinity, what does f of x do? When x goes to negative infinity. That's how we segue to the calculus. Technology and get a graph. But I'm hoping as we leave this class, we estimate what the graph looks like before we use the calculator. So an exponential function, e to the x is always positive, and it's increasing. And it has a horizontal asymptote. And e to the x, it's when x is 0, e to the 0 is 1, the parent function has a y-intercept of 1. So before we use the calculator, we know what e to the x looks like, and now we apply the transformation. What does the subtract 4 indicate? Down. So we're going to go from 1 down 4 units. 1, 2, 3, 4. And we end up at a y-intercept of negative 3. Exponential functions are increasing. And they have a horizontal asymptote. So in the multiple choice, they may not have put the dotted line, but they'll have the rest of the graph. I've got 3 follow-up questions. What is the horizontal asymptote of that transformed graph? Negative 4. Because originally the horizontal asymptote was 0. Good. Okay. Follow-up question. As x goes to infinity, what happens to f of x? As x goes to infinity, the corresponding outputs get bigger and bigger without bound. That's why we put an infinity. However, in the other direction, f of x is bounded. Complete the statement. As x goes to negative infinity, yeah, the outputs get closer and closer to negative 4. In this case, they don't reach it, but in other cases, they do. Final example. Do you know what to expect in terms of shape and y-intercept before you graph it on your technology? 1/2 e to the negative x. So what does this negative tell you about the shape of the graph? It's going to be flipped somehow, a reflection. I don't know. So look at the outputs. Are the outputs positive or are the outputs negative? 1/2 is positive, and e to anything is positive. So it doesn't flip it down, because these outputs are all positive. So it reflects it around the y-axis. Yeah, it's a decay function. It's going to be a decay function. But the y-intercept is not 1 unit. The y-intercept is half as big. I'm not drawing it very well, but it's a decay function. It's hard to tell much about it, except it's been shrunk by a factor of 2. And
My initial thought is that if it was going to, we had gravel widened.
yes,
Wouldn't it? Would it-
same.
That's the same thing?
Because the parent function would be more like
So by moving it down, you had kind of widened it?
no, I squished it. So every ordered pair, you squish the height by half.
Okay.
Yeah, so it went. That's the one I'm drawing. So what should be on your radar? Emails coming out with some extra credit. Test 5. Test 5, there's some room for growth. Doesn't hurt to go back over that test, rework it, and maybe compare and contrast with the PDF. If you haven't printed off the PDF,